Welcome back, class. Thank you for joining me once again for our 4-2 notes. For these day 2 notes, we're going to begin by just reviewing the pieces of graphing. So, when we're graphing something in standard form, first things we need to know are what are A, B, and C. A is always a number with the x squared. B is always a number with the x. C is always a number that's by itself. So when we're using that negative b over 2a, well, b is already negative 4. So the opposite of negative 4 is a positive 4. And then 2 times a, 2 times negative 2, means we're dividing by a negative 4. So essentially, we're getting an x of negative 1. So that's the x value of our vertex. Now to find the y value of our vertex, remember we're plugging that back in to the original equation. Now, we have to be extremely careful with our signs here. So for that first term, negative 1 squared is a positive 1, but when you times that by negative 2, you actually end up getting a negative 2. Negative 4 times negative 1 is a positive 4, and then plus 1. So we have negative 2 plus 4 plus 1, or that's going to give us a 3. So our vertex is at negative 1, 3, or right there. Next thing we do, we take that x value of the vertex and we create our axis of symmetry through the vertex. Because after we've done that, we can identify the y-intercept. So remember, the y-intercept always comes from that c value, because when we plug in 0, it's all that's left. So we get our y-intercept at 0, 1. Now, to mirror that point, notice it is 1 away from our axis of symmetry, so I get an identical point 1 away on the axis of symmetry in the other direction. And that gives me enough so I can finish my parabola. Now, don't forget, when you're doing these, you have those additional pieces that you're going to be asked to find. So you can tell the vertex here is the highest point. So that is going to be our maximum value. The domain, remember, is always all real numbers. And the range is based on the y values. In this case, since it is the maximum value, every y is going to be less than or equal to the vertex. So every y is going to be less than or equal to that 3. So that's just a quick recap of our graphing. The real focus of this notes is going to be word problems. So looking at these word problems, the height of a ball thrown upward from 5 feet with an initial velocity of 60 feet per second can be modeled by h of t equals negative 16t squared plus 6tt plus 5, where h of t is the height in feet and t is the time in seconds. So, when does the ball reach its maximum height? So, maximum height, that is referencing the vertex. So whenever you're being asked to maximize or minimize something for a quadratic, it is essentially asking you for the x value or the vertex. And to find the x value of the vertex, we use negative b over 2a. Well, here, our a is 16, our b is 60, and our c is 5. So to answer these 4 problems, we still have to identify the a, b, and c. But then all we really have to do is find the vertex. So negative b over 2a is going to be negative 60. Then 2 times negative 16 is negative 32. We calculate that out, keeping every decimal. So we get 1.875. And this is the when does it occur. So we're looking at seconds. All right, now, what is the maximum height? So what that means, The actual maximum height means we're plugging in that x we just found in part A into the original equation. So the height is going to be when we plug in that 1.875 in for t. Now notice I'm using x and t synonymously because in our equation we usually use x. This one just uses t for time. But in reality, those are synonymous. Now, when I'm calculating these out, I want you to have a calculator in front of you. I want you checking to make sure you get the same values that I do. So, when I'm simplifying this first piece, getting a number for that, I get negative 56.25 plus, look at that piece, get 112.5, still have that plus 5. Add all of those up, I'm getting a height of 61.25 feet. So again, that's what I'm getting when I plug back in that 1.875. So again, please make sure you're getting that same value as I am. And make sure you can properly plug this into your calculator. As for this last piece, when would the ball be 5 feet from hitting the ground? Now here, we're going to use some common sense, all right? So it started up at 5 feet. We want to know when is it going to hit 5 feet again? So I want you to realize this is a symmetric shape. So to reach that maximum point, it took 1.875 seconds, okay? Now, to get back down to that same height, it is going to take another 1.875 seconds. So essentially, all that's happening is to get back down to the same height on the other side of the parabola, we're essentially just doubling that distance. So it's going to take a total of 3.75 seconds to make it back down to that 5 feet that it started at. All right, moving on to our next example. The height of a ball thrown upward from 7 feet with an initial velocity of 50 feet per second can be modeled by h of t equals negative 16t squared plus 50t plus 7, where again, h of t is the height, t is the time. And we're being asked about that maximum height again. So maximum height, we're talking about the vertex. So we're going to use that negative b over 2a to locate it. Again, where a is negative 16, b is 50, c is that 7. So we're getting negative 50 over 2 times a. So 2 times negative 16 is negative 32. When I do that calculation, I get 1.5625 seconds. Right? Again, check to make sure that you're getting the same thing as I am. Now to find where that maximum height is, what is the actual maximum height? Again, all you're doing is you're plugging in that value you just found back into the original equation. So I'm going to break it down into pieces. When I calculate that first piece, I get negative 39.0625. When I simplify the next piece, I'm getting 78.125. And then that plus 7 at the end. When I add all of it up, I'm getting a height of 46.0625 feet. All right, now, when will the ball be 6 feet from hitting the ground? I'm sorry, that should actually be a 7 there, so please fix that typo. So when is it going to be 7 feet from hitting the ground? So again, I started at 7 feet. It took 1.5625 seconds to reach that maximum height. Well, to get back down to that 7, it's going to take another 1.562 or 0625 seconds. So altogether, it would take a total of 3.125 seconds to go up and come back down to that 7 feet that it started at. All right, I'm going to jump into an economics example now. A model for a company's revenue from selling a software package is R equals negative 2.5 p squared plus 500 p, where p is the price in dollars of the software. What price will maximize the revenue? All right, so again, we're talking about maximizing. So we're going to need that negative b over 2a. All right, so a is negative 2.5. B is 500, and in this case there is no number by itself. So that means my C is 0 in this case. All right? So don't be intimidated if there's only 2 terms. Still just label out A, B, and C. This time it just so happens C is 0. So negative B, negative 500 over 2 times A. Well, 2 times negative 2.5 is negative 5. So I get 100. So that's telling me that my maximum revenue will occur when the price is $100. Okay? And it wants to know what is that actual maximum revenue. Well, to actually find that, we're plugging in that 100 into the equation that we started with. So all I'm doing is I'm plugging in that 100. And when you end up calculating that expression out, you get the maximum revenue is, I apologize, is $25,000. And again, please don't just sit back and write those down. Make sure you can calculate out the same numbers as I am. Our last example. The equation for the motion of a projectile fired straight up at an initial velocity of 64 feet per second is h of t equals negative 16t squared plus 64t, where h is the height in feet and t is the time in seconds. Find the time the projectile needs to reach its highest point. How high will it go? Again, it's asking for highest point, maximum height. So we're going to use that negative b over 2a. And again, a is always a value with the x squared, b the value with the x, and in this case, again, there's no number by itself. So that means my c ends up just being 0, which is fine. So negative b over 2a, negative 64 over 2a, well, 2 times negative 16 is negative 32. So I'm getting 2 seconds. That's how long it takes a projectile to reach its maximum height. All right, now to find out what that height is, we have to plug that 2 back into the original equation. So I plug 2 in for the t, and I get negative 64 plus 128. I'm getting a maximum height of 64 feet. All right, so thank you so much for joining me for all of these word problems. Please make sure you have everything written out, and then I will see you in class so we can work on our practice work.